Hey, what's up guys? In this video I'm going to talk about a platform I'm working on called Rovari. It's actually based around these WCH32 chips, right? So I just have here, I have this demo setup. So this is an SD card, this is amplifier with a speaker on it. And I'm going to show you easy it is to do a MP3 player with Rovari. So we're actually walking through this stuff. I'll kind of introduce the platform, but if I'll just press play here from the PC side. Right, and actually hearing you'll actually be hearing the music. So this is playing from the SD card going to the chip and then all playing. So I'll go across to the ID now and I'll show you how easy it is to build even a project like this. So guys, this is Rovari Studio, and the idea was I wanted to be really simple, kind of like Arduino, but at the same time have a little more for who want, the little more when they need it, right? It's not to compete with Eclipse or NetBeans or your that I have set up by idols to get beginners started really simply. So we'll start a new project. Um, so we have, I'll just walk through as we go along so you kind of understand how the IDE operates. So you have your toolbar here and you'll see little tooltips, um, as you go across, right? So we could create a new project, open a project, we could create files, we could save files, we could close stuff. Now this is the ESCAT system. So you can have your editor, you could, we have your Explorer here, the snippets window, you could even toggle the code editor part. I have the A is for AI assistant, right? It's something I want to bring in, because we can't really get rid of AI, so whoever want to ask AI a question, the idea is that you could connect your API, you send a question here, and you kind of get an answer, right? Rather than having a full integration. It's kind of like it's like a search engine when you need to, you need an answer to something. Um, that's an optional feature. I'm still testing out whether it ship it with the completed ID or not. So, and then you also have the terminal, right? So you could toggle the terminal, right? So here, of course, you could build, right? But we don't have anything, of course. You will, you could, removable artifacts, which is like a clean and stuff. You could have a one-click build on Flash. You can just run the Flash only. This here is the port on board now. Because I'm using the WCH Linky actually connected right now. But of course you have the COM port for communication because that's the ecosystem, right? To communicate with the board, right? And of course here we have the where you could run your script. I'm working on debugging support. Debugging not implemented yet. That's what I'm working on currently. We have a find and replace. This of course is your library. I'll show you how that works, right? But when we get to that. And I have a code formatter here. So if you have any mistakes, you can format your code. We have the ID settings. So you could, of course, we're using the default toolchain. They could also, optimize for size and stuff like that, normal flags. You can adjust stuff in the IDE and your workspace and things like that, right? Um, so let us make sure we optimize for size. Good. Um, and of course we are about, right? This is version 1. Um, and I might release at a 1.01 or 1.02 because there's not much again to do. So you create a new project, right? You select your target, so we'll call 01. I'll call this one demo. And we have here the target MC, right? So these are supported targets right now. I'm waiting on the CH32V107, but I started working on support for that. And of course, the V307 is where it is, but I also added support for the 003, 103, 203, and the 006, right? There's a handful of chips, but the ones that I do support, the idea is to meticulously go through every library, optimize the ecosystem for that chip. So once you plug in, you have no issues with the chip you choose. So we'll use the 307, right? We create a new project, and this is the project window. So of course, Control plus plus. Now this is built on the IDE I was doing before, Rovari System Studio. So I'll link 90 videos. So if you want to the controls on the IDE, it's actually built on that. So the IDE itself, I've been working on for about 2 years. Um, but this ecosystem is about probably the past year or so. I've been really tweaking it to support the WCH chips, RISC-V environment. So this is a new project. We have the Project Explorer. Of course, you could, set active, close, all the stuff you're custom with, but nothing convoluted. And this is the system here. So we have a app.rova file. So this is your main program. Now you see stuff like serial.begin and serial.printf. I kind of copy that part from, Arduino is kind of standard these days with that. But the actual SDK is not based on Arduino. It's a total clean room implementation. And instead of set up and loop after you have app init and app run. So it's still familiar to those who probably using Arduino. So the idea is want to have a SDK that, if you're using Arduino, you'll have no problem with. Or if it is that you're completely new to microcontrollers as well, you'll have no issues grasping it. But you're able to peel back the layers. And that's one of the ways is with if you like the Project Explorer, it's the app.rover here. And you're seeing like your data stuff, you could have include your sources and your system file where you could actually view your linker script, you could view your startup script. When you build, you'll actually have stuff in your build output. And the other side is the rovari.py. So this rovari.py I'll support I created a Python package and you're actually able to interact with your board from the Python side. So each project, you don't have to, but you can have a microcontroller side and your Python side from one clean workspace. And that's everything will operate seamlessly. You don't have to worry about it. Um, so right now we have the board and connected. If you need, another COM port to select it, or you can just refresh and it'll pull for you if the board not showing up and stuff like that. So we'll actually run through the first program here. So we have our count, we have serial.begin. This actually using UART1. I actually have the SDK where you can actually have all the instances. So everything all the serial, you have instantiation and stuff. But that will be in the dock. And you have an app run where it is you actually run the program. So you have your count and we'll print something. So I'll actually run this on the board. So you click run, you'll see it going through the build system here. It's building and it will actually flash to the board, right? And it's running on the board. So on the bottom here, you have your build, your serial and your script. So you go to the serial output, we'll connect, and you see what you write is actually coming into the serial terminal. So we'll disconnect this, and on the script side, so this is the script, and we import the board, and we just have a little label and a little card, and we just read stuff from the board, and we actually put it on. We'll do a count. So we'll run that script, and actually this uses nice guy underneath. So um it actually started here already, and you see so this is the count that you have, and the nice thing about nice guy is the the hot reload. So I'll actually um let us get this portion up because I stand on another screen I can't really snap, right? So we have this here, and let's say I wanted to make this color red. Let's say we made this red, right? Let's save this here, Control S, or you could you click save on top, and we refresh, and it's red, right? So the idea is you come on this side, you have your microcontroller stuff, so we could you adjust your count, you adjust whatever it is, and then on this side now you come and you actually you could build IoT dashboards, you could build stuff really easily. So you're kind of learning Python and you're learning embedded stuff because that's what we use these. Embedded these days is not just a microcontroller, it's like a complete ecosystem. You kind of have to understand some of the scripting stuff. So you might want an app, so you might want a dashboard. And nice GUI is the vehicle for that, right? So it could actually, you know, nice guy has a lot of, libraries and stuff on that. So I'll actually show you the MP3 example. So I'll pause here and I'll show you. Right, so this is we have it here. So I got the MP3 example. Let's paste it in. So it's less than 220 lines. So around 200 lines of code. And of course I could put this in the back, but that's also the idea with Rovari is to kind of have, not hide everything from you. So, all your line stuff that should be abstracted, but we still want that because I could have done the SDK where there's MP3.play and play an MP3, but then it wouldn't learn anything. And the idea of this is to learn and learn RISC-V, right? So, but it's still very short. And we look here, we see we're using a dark, a timer. Um, we see we're doing the MP3 file read and stuff. We have the play function, and then we're using the SD card. Of course, we see the file system and the run. Now, there's not a lot of stuff, but it's really abstracted away from you. So what you'll do is you'll come in the library here. So we're using the SD card, and you see when you click SD card, automatically adds the underlying peripheral it needs. We are using the Helix MP3 because Helix MP3 is what we are thinking, and you see all the files. If you have you'll actually see all the files that we're pulling in, right? Free RTOS and LVGL is we are coming with next. So actually working on the LVGL support right now. We'll actually do timer. Um, we'll actually we'll need the dark, right? And of course, because it's FatFS, the file system, we'll actually need RCC. So we need a real-time clock, right? And it's automatically pulling the files it needs as well, right? Um, and I can actually see where the files is. So I think that's it. So we'll click OK, right? We'll click let's see if we could get to run. So we'll click run, go to this window here. Um, it'll take a while because it actually has a lot of files, right? So it's done, it's successful. We flash the board and we actually this version library, less than 28% of the RAM and like 21% of flash. So it's not bad at all, right? So we have serial here. We'll connect, we'll actually clear and I'll reset so we could see. So we see it mounted here and it's saying type define him to play. So if you type that now, MP3, right? And it reads the MP3 file and starts playing. Just now, I disconnect the board, right? And it won't have any issue. So as soon as let's say I disconnect the board for a reason, I boot back up, press connect, and we in again, right? So I try to do as much as I could to make it simple to use. So guys, this is Rovari. This is the ecosystem, and actually I'm working on a book. I think I have a sneak peek. I actually don't have it here. But actually I have working on a book fair. I'm working on docs like it's a whole entire ecosystem. So the idea is, it does come and oh, one thing I should show you is this snippets area here. So actually go back to a simple one, right? So the snippets window actually has a lot of you know patterns that you're accustomed to. So let's say you're doing a PID controller, right? So you come here, um, you click down and you have PID. Let's say a basic PID, and it populates what you need for a PID, with industry standard patterns. So if you're teaching a course on controls, you're doing let's say DSP, let's say you're teaching filters, and you're like, you teach moving average filters, you come here and you get the moving average filter added in, right? And things everything vetted and tested, and with the companion book and books because for example, a book on plan is on DSP and control stuff, and a curriculum to assist with that. You just click on it, sends it in. So these the patterns you're accustomed with and stuff like a lookup table, you want some data encoding stuff, interrupt patterns, waveform generation, um, stuff that, as embedded, you're doing embedded engineering, the patterns you kind of want to use all the time. It's just, you click and you get the snippet in, right? So this is it, guys. This is a quick overview, and I hope you enjoy the ecosystem, and over the next few weeks, I'll actually start cleaning this up, release it on GitHub because there's a lot of underlying work that goes into this because we have the IDE side and the toolchain side, and it's actually a lot to put together. And then the SDK libraries docs it's a very comprehensive ecosystem, and a really chip the cloud skill set, that taking everything in my skill set to actually make this cohesive ecosystem, because it's web stuff and microcontroller stuff and toolchain stuff and Linux stuff and Windows stuff, and it's just like a lot of things, right? So um look out for update. I'll update on the blog, I'll update probably on Reddit, I'll update on my channel here, and also subscribe. And um, as I keep developing, I kind of give updates and stuff. And the next few weeks I kind of want to have this cleaned up and ready for GitHub, and on the site kind of have a binary could just download and run and play around with. But it'll take a lot to get to that point, right? So that's it, guys. Anybody wanna have suggestions, you could comment. If it is you have a board you'd like to see supported or something like that, um, you know, you could contact me, um, send an email, comment below, and inbox me, do something, and we'll work on something, right? So that's it, guys. Thanks for watching, and I hope to see Rovari really being one of the entry point into the RISC-V ecosystem. Right? So that's it, guys. Thanks for watching.